So today I want to look at two kinds of games and then change topic a bit. And the games I want to look at are about ultimatums and bargaining. And we'll start with ultimatums and we'll move smoothly through, and we'll see why it's an easy transition in a while. All right, so the game we're going to play involves two players. There's two players. Whoops, 1 and 2. And the game is this. Player 1 is going to make a take it or leave it offer. Take it or leave it offer to player 2. And this offer is going to concern a pie. And let's make the pie worth $1 for now. All right, we'll probably play this for real in a bit, so we'll play it for $1. All right? So it's a split of a pie. We can think of the split as offering S to player 1 and 1 minus S to player 2. All right, S to player 1 and 1 minus S to player 2. And player 2 has two choices. 2 can accept this offer. And if 2 accepts the offer, then the shares are, then they get exactly the offer. Player 1 gets S, and player 2 gets 1 minus S. All right. Alternatively, player 2 can reject. And if player 2 rejects the offer, then both players get 0. Both players get nothing. All right. It's a very simple game. There's $1 on the table. I'll take it out in a minute. There's $1 on the table. All right? And our two players are going to bargain for this, but it isn't much of a bargain. Player 1's basically going to announce what the division is going to be. 2 can either accept that division, or no one gets anything. All right? Everyone understand the game? So I thought we'd start off by playing this game for real a couple of times. So why don't I come down and do that? All right. So why don't we play with some people in this row? I've been playing with that row all the time. So Ali's going to help me find somebody.
I found somebody.
You found somebody, okay. So the person behind you?
Yeah.
And your name is?
Equia.
You have to shout out to people. This doesn't make a noise. Shout. Equia. Equia, thank you. Equia. And so you'll be player 1. And player 2 will be this gentleman here, whose name is? Shout out.
Noah.
Noah, okay. So Equia, do you know each other? That's okay, okay. So Equia can make any offer she wants. We'll play this for real money, all right? So there's a real $1 at stake. You can make any offer you want. It can be in fractions of pennies if you like, of the amount of $1 that you're going to offer to Noah, and the amount you're going to keep yourself. There you go.
A penny.
Shout it out so everyone can hear you. When you stand up, stand up. So this is your moment in the lights, all right? When you stand up as well. Here we go.
I'm going to offer him a penny.
You're going to offer him a penny. And Noah, are you going to take a penny?
No.
Noah's not going to take a penny. So I didn't lose any money on that. So no one made any money. I didn't lose any money. That seems pretty good. Let's try a different couple. Let's move around the room a little bit. So why don't you, Ali, why don't you take the guy behind here, whose name is, shout out?
Gary.
Gary. All right, so Gary, why don't you stand up? And we'll let Gary play with the gentleman in here. What's your name in here?
Anish.
Anish? Yeah. All right, stand up. And do you know each other? All right, so why don't we let Anish be player 1 this time? You understand the rule of the game?
Yeah.
So make your offer.
30 cents?
Which is that?
I'll offer him 30 cents.
You're offering him 30 cents.
Nah, that's okay.
He's saying no as well. Okay. So we're not. All right. Let's raise the stakes a bit. Let's make it $10. All right. So we're not getting much acceptance here. Let me try a third couple. All right. Working my way back. So how about you? What's your name?
Courtney.
So when you stand up as well, we'll let Courtney be player 1. And actually, Ali, when you sit down, so I can do it from here. And you are.
Danny.
Danny, all right. So Courtney's going to be player 1 and Danny's going to be player 2. These weren't our dating couples from earlier, right? We're safe from that. Okay, good. All right. So Courtney, what are you going to offer?
$5.
$5, which is half of the $10.
Accept.
All right, accept. All right. So it turned out in this game that a lot of people are rejecting offers. Let's have a look at it on the board a second. Think about it a second. And we'll come back. We're not done with this couple. We're not done with any of you couples. We're going to come back to you. All right. So in this game, it has a pretty. It's pretty simple to analyze this game by backward induction. Right? By backward induction, we're going to start with the receiver of the offer, and the receiver of the offer is choosing between the offer made to them, which is in our notation is 1 minus s, and in our three examples, that was a penny, then it was 30 cents, and then it was half of it, so call it 50 cents, just to be consistent. All right? And we actually saw two of those offers rejected, but according to backward induction, assuming that people are trying to maximize their dollar payoffs here, what should we see what should we see the receiver do? They should accept, right? They should accept even the somewhat insulting offer of a penny that was made. Even that somewhat insulting offer should be accepted by Noah, right? So Noah didn't accept the offer of a penny, and let's come back over there. So Noah didn't accept the offer of a penny, and I forget who it was, but our second player didn't accept an offer of 30 cents. But we've just argued they should have been accepted. They should have been accepted. In fact, when Aquia made the offer of 1 penny to Noah, I think she assumed that Noah would accept it. Is this right? Why do you think Noah would accept it? Shout out.
Because I felt he'd be better off with a penny than nothing.
You thought he'd be better off with a penny than nothing, all right? All right, and then we saw an offer, the offer came up a bit. Who was my second offerer? Here was my second offerer. You offered a bit more. Why did you offer more?
I felt 30 was a pretty fair share. It's a lot better than nothing.
All right, 30 seems better than nothing, although not necessarily fair, but it's still better than nothing. All right, and where was my rejecter of the second offer? Who rejected the second offer? Why did you reject 30 cents?
It's just a pride thing.
It's a pride thing. It's a pride thing. All right, and pretty soon we converged onto 50 cents, which notice is nowhere near backward induction. It's nowhere near backward induction. So the third offer, which was Courtney, is that right? Why did you offer, what was it, half of it?
Because half is better for me than nothing.
Half is better than you for nothing, and you figured he's going to reject otherwise. And in fact, he didn't reject. Why didn't you reject?
Because 5 is better than nothing.
5 is better than nothing. But the 5 is better than nothing argument would have argued against making any rejection in this game. Is that right? That's right. So here's a game where backward induction is giving a very clear prediction. The clear prediction is, first of all, the second player will accept whatever's given to them, and second, given that, the first player should offer them essentially nothing, should offer them just a penny. Right? So backward induction predicts that the offer will be essentially, let's say, 99 cents and 1 cent, or even virtually $1 and nothing. All right? But in fact, we don't get that. We get a lot of rejection of these low offers, and often we get offers made much, much higher in the vicinity of half. All right? Now, why? Why are we seeing a failure of backward induction in this game? I think this is not just you guys. It's a very reliable result in experimental data. All right? So why do we see so many people in this ultimatum game both offer more and, more importantly, reject less than small amounts? Right, so let's talk about it. So one person said it's a pride thing. It's a pride thing. Let's try the other aisle while I'm here. So what's the smallest offer you would have accepted? What's your name, first of all?
Jeff. I don't know, a cent.
A cent, right? So there are some backward induction players in the room. All right, all right. Who would have rejected a cent? Right? Who would have rejected 10 cents? We should be going down at least. Who would have rejected 30 cents? Few people rejected 30 cents, not many actually. All right? How many people would have rejected 50 cents? One person even would have rejected 50 cents, right? But essentially no one, okay. So what's happening here? Why do people think people are rejecting what is essentially money from my pocket, right? There's nothing going on here, I'm just giving you money. Why are they rejecting being given money?
Like overall, the stakes are really low. So if you have any value on sort of like pride, what people said, you know, it's not worth a penny or 10 cents. All right.
So it may be pride going on here. So certainly one thing is about pride. It turns out that people do this even in quite high stakes games. But you're right. Certainly that trade-off is going to start to bite. All right. What else is going on? So I agree. Pride is part of what's going on. What else is going on here? Let's try and get some conversation going. There's somebody in here. I can get the mic in. Shout out your name and really shout.
Peter.
Yeah, go on.
Change is cumbersome.
Change is cumbersome. Okay, you didn't want the change. Okay, fair enough, fair enough. But if the stakes go up, that would get rid of that. Yeah.
Maybe people are tying their own outcomes to the other player's outcomes as well.
Right, so maybe people have different payoffs here. Maybe people are comparing their payoff to the other person's payoff. That certainly seems like a plausible thing to be going on here. You might feel less happy about getting 20 cents knowing the other person's getting 80 cents, for example.
You might be trying to teach them a lesson to get them to offer more.
Right, you might be trying to set a sort of moral standard here. All right, so there's some notions of indignation or even teaching people that they really should offer people more. All right, what else could be going on here? Yeah.
If people know I'm not going to accept less than 50 cents, then they should give me 50 cents by backward induction.
Right, so part of what's going on here, actually this game was a one-shot game, right? We just played it once, and we could have played it, in fact they often do play this way in the lab, you could have played it without anybody knowing who the other player was, all right? But particularly in this setting where everyone can see everyone else, and even in the lab where people actually can't see people, but they might imagine that the game is really repeated, you could imagine people trying to establish a reputation. Is that right? So there's lots of these reasons. There's sort of moral indignation reasons, or teaching a lesson reasons, pride reasons. There's also this basic reason that people might be thinking this game is, I should play this game as I would a similar situation in life where I might want to be establishing reputation. All right? So there's a certain amount of confusion going on in the game, but there's also a certain amount of a lot of things make sense. Now notice that once we've established that people are going to reject small offers in this game, once we've established people are going to reject small offers, it makes perfectly good sense to offer a lot more than nothing. All right? So it's not that surprising that once we've established the idea that people are going to reject small offers, you're going to see people making offers that are reasonably large, although not usually larger than 50 cents. Why is 50 cents so focal here? Why is 50 cents so focal? It's not a trick question, I'm just asking, why do people think 50 cents is so focal? I think it's typical that people end up offering around 50 cents. Why? It sounds fair, right? It seems fair. There's some notion of fairness. It's not clear, by the way, what ethical principle is involved here, right? It's not clear that if you're walking along the street and you happen to find $1 at your feet, that you should pick it up, and anyone else you happen to see at that moment, you should give 50 cents to. Right? That's essentially what the situation is, and you just chanced upon this $1 that I just gave you. It isn't clear that there's any particularly great moral claim to give it to someone else, but I think people read this as a situation about splitting a cake in an environment of distributional justice. They view it as a larger picture. Is that right? So it turns out there's a large literature on this, there's a large experimental literature on the ultimatum game, and there's an even larger literature on an even simpler game, in which I give people $1, I say you can give whatever share you want to the other person, and they don't even get a chance to accept or reject. Right? That's called the dictator game. Right? In the dictator game, literally, you're just simply given $1 and you can give whatever share you want to the other person. Right? It turns out even in the dictator game, people give quite a lot of money. And that suggests that there really is some notion of fairness or some notion of distributional justice going on in people's heads here, rightly or wrongly. All right? So one thing this should tell us is even in extremely simple games, we should be a little bit careful about reading backward induction into what's going to happen in the real world. And part of this is because, as I mentioned the very first day of the class, people care about other things than just the obvious payoffs, and part of it is about more complicated things like reputation and so on. All right, having said that, let's nevertheless, for the purpose of today, act as if we are going to do backward induction, and let's embed this into a slightly more complicated game. All right, so the more complicated game is as follows. All right, so we're going to have a two-period bargaining game. Two-period bargaining. In this two-period bargaining game, the beginning of the game is exactly the same. So there's $1 on the table, and player 1 makes an offer to 2, and once again we can call this offer S and 1 minus S. Just the same as before. And just as before, player 2 can accept the offer, and if they accept the offer, then this is indeed what they get. All right, but now If 2 rejects, which is 2's other alternative, if player 2 rejects the offer, then we flip the roles. We play the game again, but we flip the roles. So we go to stage 2. Right, this is everything we say up here is stage 1. And down here we go to stage 2. And in stage 2, player 2 gets to make an offer to 1. Player 2 gets to make an offer to 1. And once again, we can call this, we better be careful. Let's put 1s here just to indicate we're in the first round, and 2s here to indicate we're in the second. All right, so we make offers S2 and 1 minus S2, where S2 is that goes to player 1, and 1 minus S2 is that goes to player 2. So 2 gets to make an offer to player 1, and now 1 can accept or reject. If she accepts, then she gets her share from here. The offer is accepted. And if she rejects, then we get nothing. All right, so this game is exactly the same as playing the previous game, except we flip roles. But we're going to add one catch. The catch is this. In the first round, the money on the table is $1. All right? But if we end up going into the second round, right, so the first offer is not accepted, and we go into the second round, then part of the money is lost. And in particular, we'll assume that the money on the table is delta. Right? Where you can think of delta as being just some number less than 1. Right, so if you want a concrete example, think of this as being 90 cents. Right? So the idea here is, if you get into the second round, time has passed, it's costly, and so money in the second round I think of it as money in the second round as being worth less, or you could actually think of this cake being eaten up. Some of it's thrown away, some of it's wasted. All right, everyone understand the game? All right, so this is very similar to the previous game, but we've got this second stage coming in, and we've got discounting. So this is the idea of discounting. How many of you have heard the term discounting before? All right, so you probably saw it in a finance class or a macro class, where we think about there being a value of money, value of time. That money today is worth more than money tomorrow, partly because you could put the money today into the bank and it could earn interest, partly because you're simply impatient to get that money and go and have lunch, particularly on the day in which the clock's changed. All right? Okay, so let's try this game again, and let's just play it for real. So let's come down again. Everyone understand the game? Basically the same rules with this flipping around, and with the possibility that the cake may shrink. Let's see what people have learned. So who are our first pair? Our first pair were Aquia and, who was Aquia's? And Noah, all right? So Aquia, what are you going to offer? You're player 1 here, all right? But if your offer's rejected, Noah's going to get to make an offer to you. All right, so what are you going to offer this time?
$45.99. So 45 cents. Yeah, 45 cents. 46.
46, okay, so he gets 46 if he accepts the offer, is that right?
Yeah.
46 if he accepts the offer. All right.
I'll accept that.
He accepts that, okay, that was easy. So Aquia got 54 cents, and Noah got 46 cents. All right, who was our second pair? So that was, I forgot, Anish, right? And Gary, all right? So Anish, what are you going to offer this time?
I'll offer 43.
43, you're going to push the envelope a little bit.
All right.
All right, that one got accepted as well. Okay, so people are converging here. All right, and what about our third offer and receiver? It was Courtney and Danny. So Courtney?
30.
30, so it's 30 for him.
I'll accept.
Oh, 3 acceptances, all right? All right, let's find out something here. So I was hoping to get into the second round. So supposing, okay, so you accepted, that's fine. All right, no chicken sounds around the room. All right, so it's Danny, right?
Yeah.
So Danny, had you rejected, I mean you accepted, but had you accepted, what would you have offered in the second round?
45.
45, all right, 45. And would you have accepted that in the second round if your 30 had been accepted?
Yes.
Yeah, so you might have done better, it turns out, all right? Right, let's go back through to the other rejections, so the other acceptances. So my second couple, you offered 43, is that right? Right? And you said yes to 43, is that right? Had you rejected 43, what would you have offered back in return?
43.
43, the same thing back. Would you have accepted it?
He gets 47.
He'd have got 47 in that case?
Yeah, I'd take it.
You'd accepted that, okay, okay. And Aquia went first, and she offered 45 to Noah. And Noah, had in fact you rejected, what would you have offered back?
I would have also done 45.
Same thing back, and would you have accepted it?
Yeah.
Okay, so we can see here that the decision to accept or reject partly depends on what you think the other side is going to do in the second round. Is that right? So here you are. You're making. If you're in the middle of this game, if you're player 2, you've received an offer. Right? None of these offers sounded crazy. I mean, 30 cents was the lowest one, but none of them sounded crazy. And you're trying to decide whether you should accept or reject this offer. And one thing you should have in mind is, what would I offer if I reject? And will that offer that I then offer in the next round be accepted or rejected? Is that right? All right? And so if we just work backwards, we can see what you should offer in the first round should be just enough to make sure it's accepted, knowing that the person who's receiving the offer in the first round is going to think about the offer they're going to make in the second round and going to think about whether you're going to accept or reject in the second round. Is that right? Right? So that sounds like a bit of a mouthful, but that mouthful of reasoning is exactly backward induction. Right? It's exactly backward induction. It's saying to figure out what I should do in the first round, I need to figure out what I should offer in the first round. I need to figure out whether player 2 is going to accept or reject. And to figure out whether he or she is going to accept or reject, I have to put myself in his or her shoes and figure out what he or she would offer if she did reject, and what he or she thinks I would do if I got that second round offer. Is that right? All right. So let's try and analyze this as if backward induction was going to work here, as if we didn't have to worry about things like pride here. All right, so this is the game we're actually playing, so let's keep that one. And actually analyze it on the board. I want to walk us from a relatively mundane game of take it or leave it offers to a more complicated game in which there can be several rounds of offers. But we're going to go slowly, so we'll start this with 2 rounds. All right? So first of all, let's just look at the stage 1 game. The stage 1 game, and let's keep in track what the offer is and what the receiver is. This is the offerer, and this is the receiver. All right? And in the 1-stage game, the game only has 1 stage. Then we know from backward induction what the result should be. It isn't what we find in the lab, it isn't what we find in the classroom, but we know what we should get. The offerer should offer to keep everything, essentially, or maybe 99 cents, but let's call it 1, and the receiver gets nothing. Right? So again, I'm approximating a little bit because it could be 99 cents and a penny, but who cares? Let's just call it $1 and nothing, if it's a 1-stage game. All right? So now let's consider a 2-stage game. All right? In the 2-stage game, the person who's making the offer in the first stage needs to look forward, anticipate what would happen if her offer was rejected by player 2 and player 2 went forward into the second stage. Is that right? So in the 2-stage game, in the first stage of the 2-stage game, the person making the offer wants to anticipate what the receiver would offer in the second round were the receiver to reject her offer. Okay. But we can do that by backward induction. We know that in the second round, if the receiver rejects the offer, then the second round of the 2-stage game is what? It's a 1-stage game. All right? And we've just argued, at least we believe in backward induction, in that case, player 2, who is then the offerer, will offer $1, and player 1, who is now the receiver, will accept it and get nothing. All right? So player 1 in the first round of the 2-stage game wants to make an offer that's just enough to get player 2 to accept it now. All right? So let's think about this. So if player 1 offers 2 something more than what? Well, tomorrow player 2 can get $1, all right, but that's $1 tomorrow. All right, so $1 tomorrow is worth how much today if we're discounting? It's just worth delta, right? It's just worth delta. So if player 1 offers player 2 more than delta times 1, which is what player 2 can get tomorrow, then 2 will accept. And if player 1 offers 2 less than delta times $1, because you can get $1 tomorrow, but that's only worth delta, that $1 tomorrow is worth just delta today, then 2 will reject. All right? So the offer has to be exactly enough to get accepted, which is exactly delta dollars. All right, delta dollars. All right, so player 2 knows that she can get, let's put it in pink, player 2 knows she can get $1 tomorrow, so you need to offer her at least delta today to make it as good for her as getting $1 tomorrow. All right, we know the receiver must be offered at least delta tomorrow, which means the offerer is going to keep 1 minus delta. All right, so this, in the first round of the two-stage game, player 1 should offer 1 minus delta for herself and delta for player 2. And player 2 should accept that because delta dollars today is as good as $1 tomorrow. All right? Now another way to see that is in a picture. So let's just draw a picture. All right, let's put the payoff of player 1 here and the payoff of player 2 on this axis. All right, and these are, we're going to assume they're just going to maximize dollars, so there's no pride in here. And if we just look at the one-stage game, we're simply looking at this line. All right, the offers in the one-stage game, it could be that player 1 gets everything herself and gives nothing to player 2. It could be that player 2 keeps everything ends up getting everything and player 1 gets nothing, and it could be any combination in between. Right? And we argued by backward induction, although not in reality, in backward induction in the one-stage game, player 1 makes an offer to player 2, which is kind of an insulting offer. Player 1 says, I get everything and you get a penny. All right, so this is the one-stage game. In the two-stage game, in the two-stage game, if things are settled in the first stage, this line represents the possible divisions between player 1 and player 2. Right? But if we end up going into the second stage, the pie is shrunk. The pie is shrunk. Instead of going from 1 to 1, it goes from delta 1 to delta 1. Or if delta is 0.9, it goes from 0.9 to 0.9. So let's draw that line in. Right, so we get into the second stage, we'll end up being here. All right? And this goes from delta dollars here to delta dollars here, where these dollars are being evaluated at time 1. Right, so the pie is shrunk. If we get into the second stage, then, by backward induction, player 2 knows, player 2 is in an ultimatum game, player 2 will be making the offer, and player 2 says, whatever cake is left, I'm going to take all of it, and you're just going to get a penny. So if we get into the second stage, then player 2 will make this offer to player 1. All right, player 2 will say, I'm going to keep all of the whole of the pie, which in in first period dollars is worth delta. So I'm going to end up with a payoff of delta, and you're going to end up with a payoff of essentially nothing. All right? Player 2 knows that they can therefore get at least delta dollars, or delta in current day dollars worth from rejecting your offer. Since they can get at least delta current day offers from rejecting your offer, the lowest offer you can make to them is an offer that gives them at least delta. So the offer you're going to make is this offer. This is the two-stage offer. It happens in the first stage. Player 1 makes an offer that gives player 2 what player 2 could get in the second round, and gives player 2 delta, and keeps 1 minus delta for herself. All right, everyone understand the picture? So this picture is just corresponding to this table. Right? The thing people tend to get confused about here, I think, is they get confused between current dollars and discounted dollars. So we're going to do all the analysis here in terms of the first period dollars. Dollars tomorrow are going to be worth delta. There's a hand up. Can I get a shouting out? Yeah. Yes, sorry. Let's put those labels bigger. Yes. So this is the outcome if it was a one-stage game, and this is the outcome if it was a two-stage game. Right? The offer's made and accepted. All right, let's roll it forward. Let's look at a three-stage game. Let's keep this picture handy and think about a three-stage game. So the beginning of the game is the same. All right, we're going to look at three-stage bargaining. And the rules in three-stage bargaining are pretty much the same as in two-stage bargaining, but now there's two possible flips. In three-stage bargaining, in the first period, in period 1, 1 makes the offer. And if it's accepted, the game's over. All right? In period 2, so if we reject, then we go to period 2, when 2 makes the offer. And if it's rejected now, this time by player 1, then we go to period 3, where once again 1 makes the offer. So you can see where we're heading. We're heading towards an alternate offer bargaining model. I'm going to make an offer, Jake's going to either accept or reject, then he'll make an offer, and we'll flip to and fro. There's a question. Let me try and get a mic out to the question. Here you go. Yeah.
Yeah, I have a question about the two-player game. If delta
shout out so people can hear.
If delta is the best that player 2 can get tomorrow, then why wouldn't one offer player 2 delta discounted by delta today?
Good. Okay, right. So good. So I think I was confusing about it. Something behind me clear. So tomorrow, player 2 can get everything that there is. All right. So whatever pie is left tomorrow, player 2 can get all of it. All right. So call that pie tomorrow 1, and evaluate it in period $1 as being worth delta. All right. All right. That makes sense. Okay, so I think I misspoke on that, so let me say it again. All right, so every period there's this pie. All right, in every period, if it was the last period of the game, the person making the offer is going to get the whole pie. All right, but if I view that pie tomorrow from today, right, a pie of $1 tomorrow is only worth delta dollars today. A pie of $1 the day after tomorrow is only worth delta dollars tomorrow and delta squared dollars today, and so on. All right, so that's the way in which we're going to do discounting here. Good. All right. All right. So this game, if 1 makes an offer, if it's accepted, it's over. If it's accepted, then we're done. And if this offer's accepted, then we're done. And if this offer's accepted, then we're done. And in the third round, if it's rejected, then both players get nothing. All right? And once again, we're going to assume that the players are discounting. So what does it mean to say they're discounting? It means that dollars in period 1 are worth dollars. Dollars in period 2 are discounted by delta, and dollars in period 3 are discounted by delta times delta, or if you like, by delta squared. All right, and just to put this into real notions of money, if you think of delta as being 90%, then $1 in period 1 is worth $1. $1 in period 2 viewed from period 1 is worth 90 cents, and $1 in period 3 viewed from period 1 is worth 81 cents. All right? Okay. So what do we think is going to happen here? Well, once again, we can do backward induction. here we are in our picture. Let's look at the three-stage game. And once again, when we analyze, as always, when we analyze these games using backward induction, we want to start at the end. If we start at the end, we know that at the last stage, that's the third stage of the three-stage game, looks like what? It looks like the one-stage game. And in the one-stage game, we know the offerer will get everything. All right? So again, so the last stage of the three-stage game, we know the person who makes the offer, who this time will be player 1, will get everything. However, that everything is only worth delta in period $2, and it's only worth delta squared in period $1. All right? So, in the first period of this game, we know that if the offer is rejected, we know what's going to happen. So again, in the first period of this three-stage game, if the offer is rejected, then we'll go into a two-stage game. Right? We'll go to a two-stage game, and we already know what happens in a two-stage game. In a two-stage game, the person who gets to make an offer gets 1 minus delta, and the person who receives the offer gets delta. All right? So we know in the first stage of the game that the person who receives the offer always has the outside option of saying, no, I reject, and we know that that person tomorrow will get 1 minus delta. But 1 minus delta tomorrow is worth how much today? It's worth delta 1 minus, tomorrow they're going to get 1 minus delta dollars, so today that's worth delta 1 minus delta dollars. All right? So the offer I have to make in the first round to make sure that the other person accepts it has to be just better in discounted dollars than what they're going to get tomorrow. They're going to get 1 minus delta tomorrow, so I have to give them delta 1 minus delta today. All right? Which means I keep for myself 1 minus delta 1 minus delta. And if you don't like the algebra, let's look at the picture. In the picture, in the one-stage game, this is the offer. In the two-stage game, we know if we get into the second round, player 2 gets everything, right? So we have to give him that much today. And if we get into the third round, now we're looking at delta squared here, and delta squared here. Delta squared and delta squared. We know that if we get into the third round, the person who makes the offer in the third round will get get everything. So we can actually work our way along. All right? So in the third round, the person who makes the third offer will get everything. So in the second round, you'd have to give them that much. So in the first round, you'd have to give player 2 that much. All right? Say it again. In period 3, the person making the offer can get everything. All right? So in period 2, they must be getting delta times that. So in period 1, you have to give them at least this much. All right? And this here is the offer you'd make in the three-stage game. All right? So in the picture, we're just doing a little zigzag on the chart. We're also always working across the diagonal. All right. So we've done the one-stage game. The one-stage game, the person making the offer gets everything. In the two-stage game, the person making the offer offers just enough to get the offer accepted, which is delta, because that's what a dollar's worth tomorrow. In the three-stage game, the person making the offer makes just enough to get the offer accepted, which is delta times what the receiver would get tomorrow. What they get tomorrow is 1 minus delta, so they get delta 1 minus delta today. All right? How about the four-stage game? Let's see if we can do that. So if we go to the four-stage game now, in the four-stage game, if the person receiving the offer rejects the offer, then tomorrow they can get 1 minus delta, 1 minus delta. So I need to offer them enough now in current dollars so they will prefer that to getting 1 minus delta, 1 minus delta tomorrow. So how much must I offer them? I have to offer them at least delta times that much. So I have to offer them delta times 1 minus delta times 1 minus delta. Like this. All right, and again, I have to keep the rest, I'll keep the rest for myself, so I'll get 1 minus delta, 1 minus delta, 1 minus delta. All right? And so the principle is always give people just enough today so they'll accept the offer, and just enough today is whatever they'd get tomorrow discounted by delta. All right? So actually this backward induction isn't so bad. All right? What makes it a little bit easier is you don't actually, when you go through an extra stage of this, you don't actually have to go all the way to the beginning. You can actually start where you were last time and just discount once more by delta. All right? Now let's see if we can see any kind of pattern emerging in this algebra. All right? So let's just multiply out these brackets. In the four-stage game, this thing is actually equal to, just multiplying through, it's 1 minus delta plus delta squared minus delta cubed. Hope it is, anyway. That's what this is. And this thing is equal to delta minus delta squared plus delta cubed. All right, just multiplying out the brackets. All right? Does anyone see a pattern emerging here in these offers? We had offers of 1 and then 1 minus delta. We could also multiply out this one. It might be helpful to do so. This is actually 1 minus delta plus, this is 1 minus delta plus delta squared. All right? Anyone see a pattern? What these offers look like? They kind of alternate, right? So let's have a look what the, rather than do every stage, shall I do one more stage to see if we can see a pattern emerging, or should I jump straight to 10 stages and see what happens? Go straight to 10, you'll say? Let's do one, no, let's do one, okay, let's jump straight to 10. Okay, so imagine that this game actually had 10 rounds. All right, so this is the 10-stage game. And let's just continue our chart down here. So here's a bit more space here. All right, 10 stages. 10-stage game. I'm going to continue my chart. And my chart says, in the 10-stage game, what am I going to get? So the offer is going to be the same pattern, 1 minus delta plus delta squared minus delta cubed, plus delta to the 8 minus delta to the 9. Everyone see that? So what I'm doing is I'm continuing the pattern from above. Right, so if I had 10 stages, I always start with a 1. The positive and negative terms just alternate, and I have as many terms as 1 minus the stage I'm in. So in the 4-stage game, I ended up at delta cubed. So in the 10-stage game, I'll end up at delta to the 9. All right, everyone happy with that? All right, so the 4th-stage offer is this slightly ugly thing. 1 minus delta plus delta squared minus delta cubed, Right, so plus delta to the 4 minus delta to the 5, etc., plus delta 8 minus delta 9. Right, that's a pretty ugly thing, but fortunately, some point in high school, you learned how to sum that thing. Do you remember what this is? What did you call objects like this in high school? Anyone remember? Objects like 1, delta, delta squared, delta cubed, delta to the 4, what are they called? They're called geometric series, right? They're called geometric series. Anyone remember how to sum them? We know that S is equal to this. Right, this is what the offer is. If there's 10 rounds, we know the offer is accepted. All right, so the way to remember how to sum it is the trick for summing it is to multiply both sides of this equation by the common ratio. So multiply both sides by delta. So if I multiply this side by delta, I'm going to multiply the other side by delta, and this 1 will become a delta. This delta will become a delta squared. This delta squared will become a delta cubed. This delta cubed will become a delta to the 4th, dot, dot, dot. There'll be a minus delta to the 8 coming from the 7th term. There'll be a plus delta to the 9 coming from the delta 8th term. And there'll be a minus delta to the 10th. All right, everyone okay with that? I just multiplied everything through by delta, and I just shifted the long one for convenience. What do I do now? Anyone remember? Add the two lines together. Let's add the two lines together. All right, so by summing, on this side, I get 1 plus delta S10. All right, on the other side, what's kind of convenient is everything cancels. The 1 comes through, I get a 1, but these two terms cancel, and these two terms cancel, and these two terms cancel, and so on, all the way up to the end, where I get minus delta to the 10. Everyone okay? All the other terms have cancelled out? All right, so now just sorting out my algebra bit, I'm going to take it on the other side. I'm going to have that the offer you make, this is what you're going to get to keep, so the amount I claim I should keep in the first round is 1 minus delta to the 10 over 1 plus delta. I should be a little bit careful about the notation here because it may be a little bit confusing. The 10 here doesn't mean to the 10th power, it's just the offer in the 10th round. Whereas the 10th here really does mean in the 10th power. Okay? All right, so if we play this game for 10 rounds, the offer you'd make would be 1 minus delta to the 10 over 1 plus delta, which means that the amount you're offering to the other side, which is 1 minus s, would be delta plus delta to the 10 over 1 plus delta. All right? So let's just summarize where we are. We started off by considering a very simple game, a one-stage take-it-or-leave-it offer. We know that in that take-it-or-leave-it offer, player 1 is going to claim everything for herself and offer nothing to player 2. Then we considered a two-stage game, which was the same as the one-stage game, except that if player 2 rejects the offer, let's call player 2 he gets to make an offer to player 1 in the second period. We know that in the second period of that two-stage game, player 2 can keep everything for himself. Everything for himself tomorrow is worth delta today. So you have to offer him at least delta today and keep 1 minus delta for yourself. Then we looked at a three-stage game. In this three-stage game, if player 2 rejects in the first round, player 2 can make you an offer in the second round, but now if you're player 1 and you reject in the second round, you get to make an offer to player 2 in the third round. We argued that in the second round of this game, the person, if player 2 rejects you in the first round and makes an offer in the second round, it'll be in a two-stage game, and they'll be able to keep 1 minus delta of the pi for themselves. So you have to offer them at least delta times 1 minus delta today for them to accept the offer, keeping the rest for yourself. Then we looked at a four-stage game. In the four-stage game, if player 2 rejects your offer, he can make you an offer, but if you can reject the offer, you can make him an offer, but if he rejects that offer, he can make you an offer. And once again, we asked, how much do I have to offer player 2 now for him to accept the offer now? He knows that if he rejects the offer, he can get this amount, 1 minus delta times 1 minus delta, tomorrow. So I have to offer him delta times that today, and once again I keep the same to myself. Right, that's just a summary of what we did, and then what we did was we cheated. We jumped to the 10th stage, just noticing that a pattern had emerged, and we found in the 10th stage This is the offer you'd make, just according to the same pattern, and it was this horrible thing. And then we used a little bit of high school math to simplify this thing, and it turns out this is the amount you'll keep for yourself, and this is the offer you'll make to player 2. All right, in each case they'll be accepted. Did I make a math mistake? Thank you. Yes, let's put a superscript in here. Thank you. Good. All right. So what do we observe here? So the first thing to observe is in the one-stage game, if we believe backward induction, you certainly want to be the person making the offer. In the one-stage game, in the ultimatum game, there's a huge first mover advantage. In the two-stage game, it's not clear if you want to make the offer. It depends on how large delta is. But if delta is a big number, like 0.9, you'd rather be the person receiving the offer. In the three-stage game, it looks like you'd probably rather make the offer, but it's not so clear. Right? So where does it go to as we go down the path here? As it goes down towards the 10-stage game. Looks like in the 10-stage game, you'd probably still prefer to make the offer than not, but they're certainly much closer together than they were before. Some of that initial bargaining power has been washed out by the fact there are 10 stages. All right? So let's try and push this just a little bit harder. Instead of looking at the 10th stage offer, what if we look at the infinite stage offer? So what if in principle, we look at the infinite stage of this game? All right? So I can make you an offer, you can say no and make me an offer, and then I can reject and make you an offer, and then you can reject and make me an offer, and so on and so forth. All right? So we look at this term. If in principle you could make an infinite number of offers. All right, so what's this term going to look like if I can make an infinite number of offers? So I claim it's going to look like this. 1 minus delta to the infinity over 1 plus delta. And over here, it's going to converge towards this. It would be a bit more formal. And over here, we'll have delta plus delta to the infinity over 1 plus delta. However, now I get a little bit simpler. What is delta to the infinity? It's 0, right? So 0.9 times 0.9 times 0.9 times 0.9 times 9.9 and 0.9 is 0. So this last term disappears, as does this one, and we just get 1 over 1 plus delta and delta over 1 plus delta. So if we make alternating offer bargaining, a bargaining game when each round I make you an offer, you can accept it, or you can reject and make me an offer, and we imagine there's no bound to this game, it just goes on arbitrarily long, then our prediction is that player 1, the person who makes the first offer, will get 1 over 1 plus delta of the initial pi, and player 2 will get delta over 1 plus delta of the initial pi. Let's try and get a handle about what those numbers are. All right? So if you imagine these offers can be made fairly rapidly, right? For example, I can make an offer today, you can make an offer back to me in half an hour's time, and then I can make an offer back to you in half an hour's time, then it's reasonable to assume that the pi is not shrinking very fast. Right? The discount factor is not a big deal here. All right? So if these offers can be made in rapid succession, then we might think that delta itself is approximately 1. The pi isn't shrinking very fast. If delta is approximately 1, right, if we take delta to 1 here, right, that time isn't that valuable given how rapidly we can make offers to and fro, then what does this make this equal? In the case where delta is equal to 1, what do we get? We get a half, which means this will also be a half. So we learn something from this which is kind of surprising. If you do alternating offers, the sort of standard, very natural game of bargaining, sort of the kind of bargaining you might do in the bazaar in a market, or the kind of bargaining you might imagine going on in negotiations between baseball players or their agents and teams or general managers of teams, right, which offers just go to and fro, and they go to and fro fairly rapidly, and in principle they could make lots and lots of offers. In principle, what this model tells us is, in principle, we're going to end up with each side splitting whatever the pie was equally. Right? Very, very different from the ultimatum game, where all the bargaining power was on the person who made the first offer. All right? All right, so what are the lessons here? What can we conclude from this? We've looked at alternating offer bargaining, and we've concluded under special conditions, we've concluded that you get an even split. Right? So you get an even share, an even split, 50-50 split, if three things are true. The first thing is there's potentially infinite many offers, potentially can bargain forever. And if discounting is not a big deal, what does discounting really not being a big deal means? It means those offers can be made in rapid succession. All right, so no discounting. No discounting, or if you like, rapid offers. If you had to wait a year between every offer, then that discount factor would be a big deal. But I actually made a third assumption, and I made it without telling you. What was the third assumption I made? I snuck a third assumption past you without telling you. What was that third assumption? Let me get the mic again. So I claim I snuck a third assumption. There was somebody. Well, let me start over here. What was the third assumption?
I don't know if this is what you're looking for, but they know how big the pie is.
They know how big the pie is. That's true. That's a big deal, actually. It's true, but there's something else going on here. What else is going on here?
We assumed that both players were rational.
We assumed that. That's true, but we've kind of been assuming that throughout backward induction. You're right. None of this backward induction would apply so cleanly if we didn't assume that. What else did I assume here? It's hidden, actually. I snuck it in.
Discount factor is a constant?
We assume the discount factor is a constant. That's true, but not just constant, but something else. You're on the right lines. They're the same. Right? I've assumed here, implicitly, I've assumed that both people are equally impatient. They have the same discount factor. The same discount factor, delta 1 equals delta 2. Why does that matter? Well, let's just think about it intuitively a second. Suppose that one of these players is very, very impatient. They need the money now. If it's cake, they need the cake now. They're very impatient. And the other person is very patient. Right? They can wait forever to get this bargain to come across. All right? Who do you think is going to do better, the patient player or the impatient player? The patient player is going to do better. Right? The patient player is going to do better. The way we ended up, the way we did all this analysis is we assumed that those discount factors were the same. We assumed that each person was discounting time at the same rate, perhaps because they were facing the same bank with the same interest rate. But in practice, often one side is going to be in a hurry to get the dispute resolved, and the other side can sit around forever. Right? And in that world, the side who can sit around forever is going to do much better. All right? Now we're going to look at relaxing this assumption, and this assumption in particular, we're going to relax it on a homework exercise. All right, so in your homework exercise, you're going to try redoing part of this analysis, good practice anyway, but doing it in a setting where the discount factors are different. All right. So one thing we learned here was, yes, you get an even split, but it depends on these three assumptions. All right? And it's kind of important because when you think about bargaining, I think a lot of people simply assume intuitively that whatever the bargain is about, people will eventually split on the middle. When you're bargaining about a house and what price you're going to pay for a house, all these things, you kind of implicitly have this assumption that you're going to end up splitting the difference. What I'm arguing here is you will split the difference in this natural bargaining game, but only under very special assumptions. And in particular, the assumption of patience is critical. All right? All right. There's another remarkable thing here, though. It's also hidden. So not only did we end up with an even split, but something else remarkable happened in this bargaining game. What was the other thing, somewhat amazingly, very unrealistic thing that occurred in this bargaining game? Let's see if we can spot it. So one thing was an assumption I made, and the other is actually a prediction. Yeah?
So the first offer will be the offer that's accepted?
Good. Good. Did everyone see that? So in this bargaining game, I set it up as alternating offer bargaining. So the image you had in your mind was of haggling. I made an offer. You guys thought about this offer. Shall I take this offer? No, maybe I won't take this offer. You make me an offer back to me, and we kind of haggled to and fro. But actually, in the equilibrium of the game, none of that happened. That all happened in our minds. We thought about what offer we would make, and we thought about what offer you would make back to me if I made you this offer and you rejected it, and so on. We did this backward induction exercise, but it was all in our heads. Right? In this game, the actual prediction is the very first offer is accepted. The very first offer is accepted. There's no haggling. There's no bargaining. All right? Now that doesn't seem very realistic. Right? There's no haggling. Backward induction suggests that we should never see bargaining, but never see the actual process of bargaining. What we should see is an offer's made and it's accepted. Now, what is it about the real world that allows for haggling to take place? And if this was a model of the real world and we believe in backward induction, then we're done. So why is it, in fact, in the real world, we see people make offers to and fro? What's different about the real world than this model? All right, let's talk about it a bit. How many of you, you must have all bargained for something in the real world. None of you probably bargained for a house yet, but you might have bargained for a car or something. All right? And in the real world, you make offers go to and fro, right? What's going on? Why are we getting offers in the real world, whereas we don't in this game? What are we missing? Yeah, let's try up here.
In the real world, you don't actually know what the other person's discount factor is, therefore you have uncertainty as to what your highest possible offer can be.
Good, good. So in the real world, unlike the model on the board, not only are those discount factors different, but you probably don't know how patient or impatient the other side is. You can get some ideas about how patient or impatient the other side is by looking at their characteristics, for example. For example, if you know that the person you're bargaining with over their car, you're trying to buy their car, and they're a graduate student who's just got a job in, I don't know, Uzbekistan or something, and they ain't going to be taking their car with them, and they're leaving next week, you know they're in a hurry. All right? So there's times when you're going to know something about what other people's discount factor is, how patient they are, but lots of times you're not going to know. All right? So one thing is, you just don't know what the discount factor is. By the way, what else might you not know about the other side? What else might you not know? Yeah?
How big the surplus is that you're splitting.
Good. You might not know this good that you're selling. You might not know. We've been talking about there being one pie which you're carving up, and everyone knows the size of the pie. Right? But in the real world, I might not know this object that's being sold. I might not know how much this object is worth to the other side. And he or she may not know how much it's worth to me. Right? So that lack of information is going to change the game considerably. In particular, I might want to turn down some offers in this game in order to appear like a patient person. Or I might want to turn down some offers in the game in order to appear like somebody who doesn't really value this all very much. All right? And in so doing, I'm going to try and get you to make me a better offer. All right? So what's going on in haggling and bargaining, according to this model, what's missing in this model, is the idea that you don't know who it is you're bargaining with. You don't know how much they value the objects in question. You don't know how impatient they are to get away with the cash. All right? So it's a big assumption here, very big assumption, is that everything is known. Right? So both patients, both the size of the pie, or let's call it the value of the pie, the value of the pie and the value of time is assumed to be known. But in the real world, you typically don't know the value of the pie to the other side, and you typically don't know how much they value time. All right, so that produces a whole literature on bargaining, none of which we really have time to do in this class. It's a pity because bargaining is kind of important. So instead, I want to spend the last 5 minutes just introducing, well, is it really worth introducing a new topic in the last 5 minutes? No, I don't think it is. Let me talk a little bit more about bargaining rather than that. All right. So what does this suggest? Right? What does this suggest if we're going out in the real world? All right, actually taking this to reality. Right? So one thing it suggests is people for whom it's known that they're going to be impatient, people for whom it's known that they desperately need this deal to go through, are going to do less well in bargains. Right? We already know people may do less well in bargaining because they're less sophisticated players. But here, it isn't that they're less sophisticated, they can be as sophisticated as you like, but they're just going to be in a hurry. Right? We already talked about the graduate student who's leaving for Uzbekistan. Right? But who else typically in bargaining is going to need cash now? Who else is going to be in a weaker position when they're bargaining, just socially in our society? I'm trying to get these questions out here, yeah?
In labor management disputes labor.
So that's a good question, right? It's a good question in labor management disputes. There's one going on right now in Hollywood. It's not clear there, right? It could be the management side who's in a hurry because they just need right now to get David Edelman's script written. Right? That would tend to favour labor. But it could be the labor side. Why might it be the labor side? So, did everyone know this? There's a writer's strike going on in Hollywood right now. All right. So the people on the management side who are in the weakest position are the people who are in the most hurry to get this resolved, and those are guys with the fewest scripts in the pipeline, and that tends to be late-night TV shows. So those guys really want this thing settled fast. They're in a weak bargaining position. On the other hand, there may be a reason why Labour's in a weak bargaining position. Why might Labour be in a weak bargaining position relative to management?
Rents to pay?
Right, they have rents to pay. They have immediate demands on their cash. Right, the typical worker is typically poorer than your typical manager, not always, but typically. All right, and they just have to pay the rent. They have to feed their children. All right, so there's a more general idea there. More generally in bargaining, the people who are poorer typically, this isn't just poor in terms of income; it's poor in terms of wealth. Are going to be more impatient to get things resolved. And that's going to put them in a weaker bargaining position. Hang on a second. So in bilateral bargaining, right, having low wealth and being known to have low wealth puts you in a weaker position. And that means that typically people who are poorer are going to do less well, although the late-night TV show may be an exception. All right? All right? Makes you think a little bit about whether just setting up a bargaining position makes things equal for everybody. All right? Any other thoughts about who has strength and who has weakness in bargaining? What other kind of stunts do we see people do in bargaining? What else is kind of missing here that we need to think about? What we want to do in this class is develop these ideas and take them to the real world. So what other real world things here are kind of missing? Yeah.
Usually people will make their first offer a lot higher than what they're actually willing to accept.
Right, so typically you're right. Typically people typically bargaining isn't just a series of random numbers. Typically people start out high and then they concede towards the middle. Is that right? So if I'm the buyer, I start out with a low price and come up, and if you're the seller, you start off with a high price and come down. All right? So again, that seems to be about establishing reputation and trying to indicate how much I want this good. All right? There's something worth saying here, which we haven't got time to do in this class, and I hope you'll have time to take if you take the follow-up class 156. We can actually show formally that in a setting in which buyers and sellers are bargaining, and buyers and sellers do not know how much the good is worth to the buyer or how much it costs to the seller, typically you cannot expect to get efficiency. I'm going to say that again. Right? So it's kind of an important economic fact that's missing from 115 and unfortunately missing from this class. But if we go to a more real-world setting in which people's values are not known, not only are the offers not accepted immediately, and not only is there some inequity in that the poor tend to be more impatient and do less well, but also you get bad inefficiency. And the inefficiency occurs essentially because the sellers want to seem like they're hard, and the buyers want to seem like they're hard, and you get a failure for deals to be made. All right, so some deals are actually going to be lost or take a long time in coming. You're going to get some strikes before the deals occur, and that's all inefficient. All right, so bargaining, not in this model, but in the real world, tends to lead to inefficiency. All right. So I'll leave it there. We'll have an early-ish lunch since we're all starving because of the clock change anyway.